Hello students, extremely sorry that yesterday I did not submitted any videos, and exactly I am very busy, and that's why it's a little bit difficult to upload videos or taking the classes. But today I have taken a very small topic, and that's the relation between zeros and the coefficient of any polynomial. Maybe the topic is very small, but the use of this topic is they are a very large scale in your syllabus, so that we should know the basic concept regarding this. To discuss whatever the chapter, I want to share one thing. Just you come to this point. This first you see, suppose I am considering one polynomial, that p of x is equal to ax square plus bx plus c, and whenever we are considering this polynomial, obviously this is a binomial, no? Since the highest degree of the polynomial is 2, and therefore it's a binomial, and since it is a binomial, that is degree is 2, and therefore it must have two zeros, say alpha and beta. Be careful regarding this. The number of zeros depends upon the highest power of the polynomial. If the cubic polynomial, the number of zeros will be 3. Suppose biquadratic polynomial, then it will be biquadratic means degree 4, that is highest power is 4, there will be 4 zeros. Now here I am considering a binomial, and so that it's having two zeros, and it is only in your syllabus. Cubic polynomial or biquadratic polynomial is not directly in your syllabus. So what we will get in this case, we will get that the sum of the zeros, that is alpha plus beta, will be minus b by a, and alpha beta is equal to c by a. The values of a, b, c you will get from this polynomial. Okay, and exactly this is the basic concept, but what exactly we need, the use of this knowledge. So come to one example. So how we will use this one to apply the knowledge to the solution of the problem. So come to this one. That's I am taking one example. Suppose p of x is equal to x square minus 5x plus 6. Very easy example I am taking here to make it understand you people. So that's why I am taking very easy polynomial. Now here the p of x is equal to x square minus 5x plus 6. So obviously if you will consider with this one here, this one, if you will consider this one, then obviously you will get a is equal to 1, b is equal to minus 5, and c is equal to 6. Of course, I think you are understanding. Just I am comparing these two polynomials here, and these two I am considering, this one and this one, so that you can understand. Now here suppose alpha beta are the zeros, then as per our concept, what we will get, alpha plus beta, that is sum of the zeros, will be minus this minus whatever the minus here, this means this minus. Okay, and now this value of b here, value of b is equal to minus 5. That's why instead of b I am putting the value minus b here. You can understand this one. Okay, and a is equal to 1. That's why here 1 is there, and so now this minus and this minus, two minuses are there, and so that this will make the total fraction as positive. That's why 5 by 1 here, and ultimately we are getting 5. So the sum of the zeros is equal to 5, and alpha beta, that is product of the zeros, is equal to c by 1. C means here 6, here c by a, so that here c is equal to 6, c is equal to 6 I am putting, and a is equal to 1, that's why a is equal to 1. So 6 by a, that is 6 by 1 is equal to 6. So what we are getting, sum of the zeros is equal to 5 and product of the zeros is equal to 6. And now suppose whether this relation is true or not, we can verify this one very easily. So I am taking another one option to verify this one. How we will get the original zeros of this polynomial. So to get the zeros of any polynomial p of x, we will put p of x is equal to 0. How we will get? By putting this expression, this x square minus 5x is plus 6 is equal to 0. Then only we will get the original zeros of the polynomial. And now here we are putting x square minus 5x plus 6 is equal to 0. Now implies that this exactly here this x square minus inside the bracket you can see 2 plus 5. This 5 I have split up 2 plus 5 because 2 into 6 only 2 into 3 we will get 6. Here 6 is there, and later on I will discuss if you will face any difficulties to factorize. So x square minus bracket 2 plus 3 bracket close x, okay, and plus 6. So this is equal to 0. Now taking common, sorry, not common, here I am taking the multiplication minus 2x, so that minus 2x, again minus plus 3x, so minus plus minus 3 and x, so that minus 3x and plus 6 as usual is equal to 0. And now if we will take common x from these two, then what we will get? We are taking x common, so that x into here x square, so that from this x square x will left, so x, and 2x here 2x. If x I will take common, then 2 will only left, so that 2. And similarly from here I am taking minus 3 as common, since from minus 3x minus I have taken common, so x will remains. But from plus 6, since I am taking minus 3 as common, so that again one minus is required, then only minus will get positive, and 2 is there, because minus 3 and minus 2 product we will get plus 6. That's all. Now again in the next line I am taking x minus 2 as common, because here is x minus 2, and next again here is also x minus 2. So this x2 x minus 2 is there, and I am taking x minus 2 as common, and so that from here x will remains, and here minus 3 will remains, so that x minus 2 into x minus 3 is equal to 0 as it is. Now since the product of these two is 0, so either the first term will be 0 or second term will be 0. That's why I am writing here either x minus 2 is equal to 0 or x minus 2 is equal to 0. Because of the product of two numbers or two expressions is 0, this implies minimum one term will be 0. Okay, and now x minus 2 is equal to 0, this means x equal to 2, or x minus 3 is equal to 0 imply x equal to 3. And so that now we can say that what we can share here, that this means two zeros of the polynomial are 2 and 3. Okay, we are getting real zeros of the polynomial. So in the next step we can get now sum of the zeros equal to 2 plus 3. 2 plus 3 is equal to 5. While here also we have got sum of the zeros is equal to 5. Here also original zeros are giving 5. Now product of the zeros is equal to 2 into 3 is equal to 6. Here also the product of the zeros alpha beta is equal to 6. So that this relation absolutely true, and by this verification we are getting everything. Okay, and later on in the next videos I will give you more examples, a little bit tough examples, but the knowledge will be the same. You don't go through any another way, and of course you see these videos a number of times so that the next videos whatever I will upload you can understand very easily. Thank you.